5 ways satellite technologies can help reduce emissions. Recent research has shown that satellite technologies could make it possible to dramatically reduce emissions. Applications include aviation, shipping, road, rail, energy and land use. The challenge is a lack of economic investment and integration of space and satellite technologies into global net zero planning. The space sector has played an integral but overlooked role in emissions reductions for years. Earth observation satellites for weather forecasting and climate monitoring are just one example. But recent research has shown just that global leaders have overlooked the enormous potential that satellite technologies have to help reduce emissions. For the first time, the report quantifies the carbon tons per annum that major industry sectors, those accounting for 60% of global carbon emissions, could save by using satellite technologies. Our research found that the full adoption of existing and developing satellite-enabled technologies could make it possible to reach net zero by as early as 2040, 10 years ahead of schedule. While this doesn't suggest that space is the primary solution to tackle climate change, the study has shown that its potential is significantly underestimated. Here are just some of the examples. 1. Reducing emissions in aviation. Current global commercial aviation emissions are estimated at 0.92 gigatons CO2. Rising consumer demand means this is expected to almost double by 2050. However, satellite-enabled communications technologies can improve operational efficiency and reduce wasted emissions. Air traffic controllers could select shorter or more efficient flight paths to deliver increased fuel efficiency and thus save emissions. 4D trajectory management and enhanced digital capabilities can allow controllers to let flights fly safely closer together, again reducing fuel use. Improved planning and air traffic control can also help flights reduce inefficiencies caused by altitude, speed and weather, which account for approximately 75% of excess fuel use in the industry. The other 25% comes from en route flight extension, for example when airplanes are instructed to circle airports before landing. All this can be optimized with improved data provided by satellites. 2. Optimizing global shipping. Maritime emissions are estimated to be 1.1 gigatons CO2 per year. As in aviation, this number is expected to rise to 90 to 130% higher in 2050, compared with 2008 levels. Space technologies could enable semi-automated or controlled speeds so ships move at pace with the lowest carbon impact. Autopilot systems could also help save another 1.6% of fuel consumption, according to our research. Weather routing and voyage optimization could also reduce the distance of routes and the time vessels are at sea. On board, satellite technologies could enable a raft of improvements, like trim optimization, fuel oil consumption reporting, asset monitoring, and motion monitoring to give crews more data about vessel performance. This means crews could proactively fix mechanical or system problems, with obvious added benefits. Like and subscribe. 3. Revolutionizing road and rail networks. Satellite communications technologies, predominantly based on global navigation satellite systems, GNSS, and telemetry, could deliver dramatic reductions in emissions. Eco-driving systems that recognize driving behavior and provide on-trip advice and post-trip feedback could achieve a CO2 reduction of 5 to 20%. Looking further into the future, fully autonomous vehicles will not only take drivers out of the equation, but also take them off the ground. Urban air mobility will use small, highly automated, all-electric aircraft to carry passengers and cargo in heavily populated areas. Drone delivery testing is already well underway. Reductions are also possible in rail. Real-time communications and telemetrics can improve the speed and effectiveness of communications. This allows for journey optimization and planning, which leads to better predictability and more efficient fuel or, in the case of electric trains, energy use. This is already being done by Brazilian railway operator Rumo. 4. Creating more efficient energy systems. Emissions from fossil fuel production accounted for about 18% of energy sector supply emissions in 2019, primarily from methane leaks. Fortunately, there is a way to dramatically reduce these figures. And it relies on the real-time knowledge and control that satellite communications-enabled technologies offer. Methods like GPS tracking of high-value assets, machine-to-machine solutions for monitoring, automating and optimizing equipment, and remote leak detection can make an enormous impact. Using remote cameras, gas sensors, uncrewed aerial vehicles and satellite imaging could help the industry reduce its environmental impact by as much as 10%. In electricity distribution and heat production, satellite technologies can enable advanced metering, distributed automation, and the advent of smart grids. 5. Redefining agriculture and land use. Satellite communications are already allowing the removal or avoidance of 0.3 gigatons in this sector. However, this could rise to up to 1.9 gigatons with universal adoption, mainly through precision agriculture and protecting the Earth's forests. Improving farming includes using Internet of Things, IoT, technologies connected by satellites to reduce waste and increase productivity using smart sensors, automated irrigation systems which use less water, and even self-driving tractors or automated crop scouting drones. Variable rate, VR, technology, which gives farmers better data about how to manage individual fields, can reduce the use of pesticides and fertilizers required. Increased navigation provided by satellites can also provide driver assistance and auto-guide machinery. Of course, space also has work to do to reduce its own impact, which is why last year Inmarsat worked with the Science Based Targets initiative to reduce our Scope 3 emissions by 28% by 2030 and reach net zero by 2050. Some of the examples mentioned above are simpler than others to implement, but the barriers to adoption are not technological. The challenge is a lack of economic investment and integration of space and satellite technologies into global net zero planning. It is time governments and industry leaders around the world reassess their decarbonization strategies and look at space as a real-life option to tackle climate change.